Anyway, let's go ahead and we'll remove this sphere 02, and now we're going to say we want to use the green particles to calculate the collision on that sphere. Go ahead and enable the matter waves born, and let's take a look what we have. Get a bunch of these particles flying out. This map is still being displayed right now, but we're going to go ahead and we'll recalculate the collision using these particles. One thing we do want to do, we're going to turn off blow up so the collision map does not spread over time. And we'll just go ahead and hit record here. Put you on pause. Okay, and here we go. Now we'll go ahead and we'll turn off the matter waves born to keep them out of the viewport, and we'll just see that these white marks start appearing over the surface. And this is all the locations where particles are hitting. You can see something interesting here on the right side. This particle seems to kind of smear all the way across there. This is because of the scan depth, remember the ray length that it's calculating. If we turn on the matter waves and we'll look and see where that particle is, we can see that it's this particle here who is calculating that mapping. So he goes here, there's another mark there. You can see these are kind of rough. You would want to increase the number of subsamples and increase the map width and height. This is going to increase your adjusting those is going to increase your calculation time, so you'll notice that really quick. But this scan depth is saying, okay, well, even though this particle is inside of this sphere, he's still within 10 units of this surface. So go ahead and paint that surface. So that's what scan depth will do for you. We're going to go ahead and jump a little bit ahead. We're going to go ahead and turn on blow up, and we'll set that to 10. And what we're going to do is go ahead and recalculate this map, and then we're going to go ahead and use it in conjunction with a fragment. So let's go ahead and record. Put you on pause. Okay, and there we go. Let's go ahead and take a look at our result. Yeah, so you can see it's only the first few particles who end up spreading around there. That'll be fine. We're going to go ahead and do this. We're going to go ahead and just whip together a quick fragmentation sample. And let's create a new dynamic set here called born. We're going to use a object particle to turn this orange sphere into a particle source. We're going to go ahead and make him a red instance shape and hide him. Let's check that red particle, make that red. And let's go ahead and also create a new group called frags. Frags, let's make them kind of a bright gold color. Okay, we don't need the collision map anymore. We're going to disable that rule. We'll also disable the matter waves born rule. We're not using it. Go ahead and create a new rule. This will be called fragment. And here in fragment, what we're going to do is we're going to say we want to affect the red particle, and we want to fragment him. So we'll come to shape, fragment, select that there. We're going to go ahead and pick the frag mask. Let's get this over here, and we're going to go ahead and first drop that map slot in here as an instance. You can see it changes over time as we scrub. We're going to go ahead and just drop this frag mask into this slot, and go ahead and close this. And we're going to need to set a threshold value for this frag mask. We're going to go ahead and use a value of 0.1. So anywhere on that map it turns 0.1 in color, it's going to go ahead and fragment. We want the fragments to be born into the frags group, and we're going to go ahead and use visible edges only. We'll set a count of 500, and let's set their speed a little bit higher there, 50% variation, and all the rest of this should be fine. And just to double check, our object particle, the sphere, we're using an instant shape, so it's going to go ahead and use the UVs from that previous shape. And what we should see is, as that map is hitting, the collision map is spreading, we could probably use more fragments. So let's go ahead and increase our fragment count. In fact, let's just go ahead and use single faces. And what we'll see is that it's spreading over the surface because we had that blow up turned on. and it's eventually covering the whole surface. And this is where that first particle hits, and you can see it's just going to spread around. It also has gone through the back, so that's why we get the breaking there too. Okay, so just a really quick and easy way to use the collision map that we calculate between a source object and some particles, and use that to drive the fragmentation. That of course could also be used with matter waves, of course, to control where particles are emitted from, and just in general as another effect that could be used maybe with a displacement map or some other function. Okay, so this has been a quick tour of CollisionMap. Just remember that you're going to want to specify one target object, and any subsequent objects are going to be colliders on that source object, the top one. And you can specify a group, particle group as well. And remember, the scan depth is going to determine even if particles are inside or not quite reaching the surface, it can still go ahead and paint a collision map on them. And just remember that the number of subsamples and the map width and height are going to kind of affect your processing speed as well as the accuracy of what you see. So, and don't forget, blow up lower values are going to spread faster. So a value like 1 is going to spread very fast over the surface, and a value of 20 is going to go much more slowly. So it just depends what you're after. Okay.